Welcome to Inspiring Minds, powered by the Edison Awards, showcasing the leading innovators from across the globe. I'm your host, Jennifer Trammell. On the podcast today, we hear about 5G all the time, and 5G networks carry an incredible amount of data. Think about this communications network that keeps us connected. Our personal phone calls, companies doing business, the banking system. It's critical infrastructure that relies on technology that has to be secure. There's a shift happening now as network providers push for more flexibility. It's called ORAN, Open Radio Access Network. ORAN enables service providers to mix and match equipment from different vendors. But there's a growing security threat in this open environment. That's why Lattice Semiconductor created a software tool called the Lattice ORAN Solution Stack. This ready-to-use software protects communication between board components through encryption and authentication across channels. It effectively secures the wire in the inherently open ORAN functionality. Chief Strategy and Marketing Officer for Lattice Semiconductor, Esam Elashmawi, joins us here on Inspiring Minds. He's going to help us understand how this innovation creates not only improved security, but also the long-term impact of reliability and power efficiency throughout the telecommunications market. Esam, welcome to Inspiring Minds.
Thank you, Jennifer. I'm glad to be here. Really appreciate it.
Congratulations to you and the Lattice team on your Silver Edison Award.
Thank you so much. We're really excited about it. You know, the Edison Award is a very prestigious award. And to be nominated, we were really happy about that. But to actually win the award, we're really excited. Everyone within Lattice, myself, the entire Lattice team, really pleased to have won the award. It's just a testament of all the hard work and effort that we put in to bringing products and solutions to our customers that make a difference in the industry.
Well, it absolutely is an honor. We want to learn more about Lattice to get started here.
Yeah, actually, talking a little bit about Lattice, you may not know this, but we actually hit our 40th anniversary in April of 2023.
Wow, happy birthday.
Thank you so much. You know, not many companies in the technology sector can claim 4 decades of innovation. And that means that you've constantly got to innovate and bring something to the market of value. And really pleased to be part of Lattice with 40 years of innovation. And what Lattice does, for those who aren't familiar, we build what's called FPGAs. These are field programmable gate arrays. Now, if you think about today's complex technologies and systems that are being built, one thing that our customers look for, or system designers look for, is flexibility in what they're building. And what we provide in these FPGAs is that flexibility. It allows them to get to market very fast, but also to innovate with that flexibility. And what you'll find these FPGAs in, and you may not be familiar with this, but FPGAs are actually pervasive in a lot of different systems and applications. When you think about 5G networks, wireless networks, you think about servers, data centers, factories, robotics, medical systems, automotive, avionics, you find a wide use of these FPGAs. And Lattice has been innovating over the last 4 decades. We specialize in developing what we call small and mid-range FPGAs that are very power efficient, but also very small in their form factor. And that's what we specialize in. And our customers use these in a wide range of applications. Some of the things that they do in these systems that I talked about earlier, like in 5G and in automotive applications and factory, is they use these FPGAs to innovate around artificial intelligence, around security, around sending secure signals, communication, network communication. There's a lot of different things. Because they're so flexible, it allows them to implement these into their system. So you may not have known this, but FPGAs are pervasive in a lot of different systems that you actually touch on a daily basis.
Let me ask a background question so people better understand your solutions. So an FPGA is inside of a chip. Is that the right way to say it?
Yeah, so FPGA, field programmable gate array, it's a piece of semiconductor, so it's a chip. And within that FPGA, there is a sea of logic, that logic that you can configure. And there's also, think of it as a ring of interfaces that communicate in and out of the chip. And we build these very complicated tools, software tools that look very easy to our customers, where they can envision, here's what I want my semiconductor chip to do. And they will come and say, here's the digital logic, here's what I want it to do. They use our software tools and they build their design. And then through the power of our software and our chip, they can hit a button. It creates what's called a bit stream, and then our chip instantaneously gets configured to do that design. So if you're building a system in an automobile that does infotainment and sensor aggregation, the designer will go into our software tools, build that, and then we can download it into our chip, and that chip now becomes specifically for them that specific design that they wanted for their system. And that's used again across many applications, across many markets. It's a very fast way to implement a silicon chip that's customizable without actually going to a manufacturing facility and say, build it for me, because they're taking a standard part and downloading the design into that part.
It's almost like the beginning of life when you have a cell, but we don't know that this is going to be a skin cell and that's going to be a hair cell and that's going to be a heart or an organ cell. And all of a sudden, with your solutions, you can start to say, this is specifically for this action.
Exactly. So think about it as a sea of all these cells, and what cell do you want it to be? What do you want it to be? You can build it, and then it is what you defined.
Okay, so I'm thinking about this as our lives become more and more digital. Are we talking about like everything from a smart doorbell to a washing machine to a car?
Yeah, so actually, when you think about, for example, I'll give you an example, Lattice in an automobile application, you'll find us in infotainment systems. We help on display technology. We pre-process data coming from the sensors in your vehicle so that, the automotive manufacturer can then take that sensor data and do something with it. An example of that is ADAS type applications, autonomous driving applications. When you think about your home, smart home devices can leverage Lattice devices as well. And so you think about adding intelligence into equipment, then you can use the artificial intelligence in our FPGAs to make your devices smarter. A good example of that is if you look at laptops today, today are starting to adopt FPGAs for artificial intelligence applications. A good example of that, and this one is public, so I can talk about it. Lenovo has their Premier ThinkPad line of client devices. The ThinkPad has these cool artificial intelligence capabilities where if you walk away from your screen or you're not even looking at it, it actually dims the screen to save battery. It also has a use case where it uses Lattice artificial intelligence in our FPGAs, where if somebody's standing behind you, we call this shoulder surfing, which is okay. But if they're actually standing behind you and looking at your screen, you could be at a coffee shop or an airport, it'll actually notify you that someone's standing behind you looking at your screen. And then we can use these artificial intelligence that we have in our devices and these clients to create more use models. So think about things around wellness, collaboration and meetings, and making sure that the use model or the experience for the end user is optimized. So that's another example of how people are leveraging Lattice FPGAs to bring intelligence into systems.
The world is ever changing and Lattice is right there innovating. Now, FPGA then refers to the hardware, right? And you also provide software solutions. Let's talk about that.
Yeah, a really good point. So I'd say back in 2018, we made a strategic decision to invest more in the software side of our solutions, recognizing that as systems become more and more complex, we wanted to help our customers get to market faster. And in order to help them get to market faster, we started building software, what we call software solution stacks. And we built these software solution stacks around specific areas that we felt were really important to our customers. We built one around artificial intelligence that we call Sense AI. We did things around computer vision. We have called MVision, Lattice MVision. We have also around factory automation. We call that Lattice Automate. But one of the solution stacks that we also created was Lattice ORAN, and that's the one that we won the award for. And Lattice ORAN is really targeted for the communications networking environment or industry. and giving them easier solutions to be able to adapt our FPGAs so that they can innovate faster and get to market quicker with our FPGAs. We take a lot of the capabilities in our FPGAs and we package it into a software tool that can help our customers leverage our FPGA, get the most out of our FPGA as they deploy their systems into the market. And the one that we won the award for, again, that we're really proud of, is Lattice ORAN, which is one of our most recent software solution stacks that we've released.
The Lattice ORAN solution stack. Now, security starts to factor in here, right? As we think about 5G being so pervasive in our world and our lives, and your software solutions bring security into play and help with that. How?
Yeah, so we recognize also that security is something that's really, really important to our customers. And they're always looking for ways to protect their systems, not just for themselves and protect their IP, but for their customers as well that are deploying these systems. So let's take an example around what we did in ORAN and in the communications network. Communication network is deemed a critical infrastructure to most governments and countries. You can't do things without a good communication system. So when you think about us making phone calls or companies communicating with each other or banking systems, and there's a network that the traffic goes across, you really have to make sure that that system is secure. That's critical to national security. It's a critical infrastructure to everyone. You as a user, Jennifer, when you're making a call or making a transaction through online banking, you want to know that this is secure, that nobody's going to hack in and either take my password or take the information that's going through and use it in a malicious way. So one of the things that we deployed in our ORAN solution stack was not just the ability to synchronize data and communication traffic, but to also make sure it is secure. We actually monitor, we have these capabilities where we can see anomalies, and we ensure that the traffic that's happening, the synchronized traffic, is secure at the same time. And so that's one of the things that we added into our ORAN solution stack that sets it apart from what's available elsewhere. ORAN stands for Open Radio Access Network. If you look at networks today that are in the industry and you think about 5G, the way it starts off is it's proprietary networks. That means you have a large OEM that says, hey, do you need the radio in the tower that needs to communicate with the base station that then communicates eventually to the back office of your phone carrier, as an example. Well, typically, when you want to look at this entire 5G network from radio tower all the way to the back end, a lot of times these are built by large OEMs and they're proprietary networks. What the industry always pushes for is let's have things that are open. It gives the industry more flexibility, that I can use this OEM's tower or radio unit, this OEM's small cell, this OEM's base station. So the industry pushed for more flexibility, and that more flexibility also helps from a cost reduction because now you have more choices. And so the industry pushed for something called ORAN, which is Open Random Access Network, where you have better interoperability among all of these components in a network. And when you have better interoperability, then you can take one person's device here, another person's system here, connect them together. It gives everyone more freedom to selection, but also opens it up where you have more choices, which drives more innovation, lower power, lower cost as well. And so the software solution that we provided around ORAN really addresses that interoperability. And what we provide in our ORAN software solution stack is not just timing and synchronization and communication between these different systems, but we do it in a secure manner, which is very unique in the industry.
And that makes sense when you think about opening up this kind of network. You're also opening yourself up to vulnerabilities. And we've all, experienced that in some form or another, whether it's, getting an alert that your credit card may have had a fraudulent purchase. We've all experienced this, but knowing that there are solutions out there like this to say, hey, we're looking at the big picture and helping to make this a more secure experience for everyone and all of our devices.
Yes, indeed.
Now, Esam, you mentioned the low power options here and that sustainability factor. Tell us more about that.
Yeah, we pride ourselves at Lattice for innovating, not just bringing new FPGAs to market, innovating in software, but we do it in a way that really drives low power. We believe that when you look at a lot of the complex systems today, and not just within the network, but even things around generative AI and what's happening in data centers and all the compute that's happening today. A lot of that drives a lot of power dissipation, and that comes at a big cost. And in some systems, that power is the limiting factor. You're just generating so much heat in the systems. And so what we're able to do within Lattice is innovate in our products and to provide really low power solutions that don't sacrifice the performance. In fact, there's been competitive data with our parts, with competitive parts, and we're like, half the power dissipation and 2.5 times lower power. And that's significant for our customers when they're building these very complex systems. Think about having to add fans, or even when temperatures of systems start to rise, you get reliability concerns. How long these parts can last in the system. You think about, again, communications network. You have towers outside, in the summer, in the cold, in the heat. Yet they're dissipating a lot of power. That has an impact on the system itself, impact on the system development, system operating costs, and the long-term reliability. So building these low power FPGAs really, really helps our customers from their sustainability goals, but also within Lattice, we feel an obligation as well to make sure that we're providing back to the environment and our community and bringing, devices and solutions that run at very low power. In fact, we have a stat that we look at, every year with all the power that we're saving, or allowing our customers to save, how many homes can that power? And we've got a write-up on this on our website, but it's about 38,000 homes. And so it's a significant impact to the environment and sustainability. But for us, it's really important. We believe that we need to innovate in this area, and kudos to the team. They do a really, really good job in coming up with new innovative ways to really not just meet the performance, but also drive lower and lower power for sustainability.
That's awesome. Let's talk a little bit about regulation around this, both here in the United States and abroad. What does that look like in this aspect of the industry?
We read about it in the papers as well. You talked about earlier, there's always some hacking that's happening somewhere. Somebody's breaking into some network or some company's network environment, taking credit cards, etc. And let's call it the bad actors, just keep getting smarter and smarter and smarter. And we have an obligation on the other side to also continue to innovate and be smarter and smarter on how we protect our systems. And I think one of the good things about FPGAs, and I talked about this earlier on about defining an FPGA, it's that flexibility. You can take an FPGA, you can program what you want the FPGA to do, and in real time on the fly, you can actually upgrade it. So governments are pushing a lot of us and the industry to, how do you improve security, cyber resiliency? The European Commission has Cyber Resiliency Act. The US is talking also about, the executive order on improving national cybersecurity. And these are things that are going to constantly come. And I don't see them stopping. I think we'll get regulations put in place. We'll get more regulations put in place. I've been doing stuff around security now for many, many years. It's a race. It never stops. We have to get smarter. They get smarter. We have to get smarter. It just doesn't end. It's a race. But what we do with our FPGAs, which I think is pretty cool and innovative as well, is because they're flexible and reprogrammable on the fly. As new threats come, we can adapt the systems to those new threats. So even when you think about things that people are talking about today on post-quantum crypto, and how do you secure against post-quantum crypto? You get these supercomputers now that can break keys much faster than our computers that we have today. So we're already talking as an industry, okay, how do we protect against that when these post-quantum computers start to come out? And so even with our FPGAs today, we're working with many standard bodies on how do we leverage FPGAs to protect these systems. And as these threats evolve, leveraging the flexibility of an FPGA to evolve as well real time in the systems to protect against these types of attacks. But it's something that we've been working on for many years and innovating, and I just don't see it slowing down. We're going to continue to innovate in these areas as time progresses as well.
It's that race where you never really reach the finish line.
You don't. So you got to think for the long run. You just keep going, and it's for a good reason as well.
Well, let's talk a little bit about what's next. Where is Lattice headed in the future?
Yeah, we're really excited about the pace of innovation that's at Lattice over the last, 5 years. We've been introducing more products at a much higher cadence than what we've had in the past. We're excited about the investment in software. We think software is critical to our strategy, but also, again, it helps our customers get to market faster. We're building more FPGAs with more capabilities. We're driving lower power because we think that we've got a sustainability goal that we're trying to achieve with our customers. They have a common goal with us on sustainability as well. But we're going to continue to innovate and bring newer products to market that leverage not just our software, but our hardware and our FPGAs. And we're really, really excited about that.
And of course, all of that is going to require more and more innovation. So, talk to me a little bit about that. What is Lattice's philosophy when it comes to innovation?
Yeah, I'm really proud of the team. When you look at the Lattice team, we've got some cultural aspects that I think are very unique to Lattice that drive innovation. I mean, if you look at our culture, there's two things that we talk about that's really embedded in the Lattice team. One is they are very innovative, and bold. Bold is the second one. And when you have innovation and you have a team that's being bold and they're very collaborative as well, that drives a lot of innovation for us. And then you partner those three attributes of innovation, bold, and collaborative with our customer intimacy, and the fact that we have over 9,000 customers, and these are in the communications, compute area, industrial, automotive, and we speak to many, many customers. Those customers share with us a lot of their challenges. What are they trying to solve? What are their challenges for the next decade? What are the products that they're trying to build, whether it be in artificial intelligence, whether it be in security, whether it be in computer vision, et cetera. And combining our innovative, bold, and collaborative culture with what our customers are telling us, there's a lot of exciting things that are going to be coming out of Lattice over the next decade. And I'm really excited, and I'm looking forward to that 50th anniversary we have a decade from now, and talk about 5 decades of innovation coming from Lattice.
It'll be here before you know it.
It will be. It will be.
Well, I'm so glad you could join us on Inspiring Minds today. Thank you, Esam.
Thank you, Jennifer. I really appreciate the time.
You've been listening to Inspiring Minds, powered by the Edison Awards, where we showcase leading innovators from across the globe. I'm Jennifer Trammell. Thank you for tuning in, and we look forward to having you join us for our next conversation with another inspiring innovator.